So what is up everybody? So since we have another package list to tackle, so basically here I'm gonna show you what are we gonna be tackling today. So as you can see here, we have multimeter, but my multimeter is broken, bro. Look at this. What kind of multimeter is this, bruh? But this I mean, it's not that broken, it's still usable, but it got no battery. It got no battery. See, it's supposed to turn on, but well, you get the point. But we have 1, 2, 3, 4 topics we need to understand today. First is, I know why polarity matters. Next and is, y'all can read that shit. Okay, so first, why does polarity matter? Why does polarity matter? Oops. Okay. Boom. Beginner electronics number 12. Yeah. Why does polarity matter? In a circuit, it matters because your component won't in the correct way. In the correct way. Boom. So that's it basically, right? So let's make a magic. 1, 2, 3. Boom. So basically, polarity matters because if the positive or the negative is not in the correct way, your components would not work, right? Basically, you have to get the right polarity, or which is the negative and which is the positive for your things to work, right? Basically, that's it. You just gotta understand where the positive goes or the negative goes. That's it, bro. Okay, next is, what's next? Next is, I understand why too much current destroys components. So, okay, new topic. 1, 2, 3. Basically, guys, too much current is like, you know, when an electron travels, right? It has dots. Let's get this thing. Hold on. Let me close this noisy ass fan. Okay. So, see, this is a wire, right? And then this is an LED. Pop, 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 pop. And let's say this is 12 volts. And it produces a bunch of current. Let's just say that's the battery. Okay, so when electron travels, they travel at certain speed, which we call an current. So when they pop, this is the electrons, right? If they travel so fast in this component, it will eventually heat up. It will heat up. So the faster the electron travels, which is we call a current or an amps, the component will heat up very fast and causing the electronic component to burn. So that's why they have specific types of voltage and current depending on their product made, I think, like that. I don't know how they made. it. So they have specific current and voltage for the component. That's it. Okay, so that's it. Why does too much current destroy component? Basically, when electrons travel on a component, it produces a small amount of heat. But small amount of heat. But if the electrons travel so fast in a component, it would produce so much heat. So basically, uh, when that's an electron travels so fast in a component, it would produce heat that will burn the component. So basically, that's why too much current can destroy your component. I should add this heat, I forgot. Heat. Lol. Oh, and what's next? Okay, what's next is I know why motors need separate power handling. Wait, let's ask Gemini. 1, 2, and look. Okay. Right. Oh, oh. There are two reasons that the voltage, the motors need a separate power supply. Basically, number one is the kickback. Basically, when I guess when a motor runs, it it sometimes kicks back a bunch of electricity or voltage, which would fry components that got affected by the voltage spike, which is too much for them. Meaning, the motor could kick back a bunch of electrons or electricity, which would be sometimes dangerous for your component because they can't carry that type of electricity or that type of voltage or current. That's why they would break or burn. And number two, they would suck all the voltage out. Basically, that's it. They're not only selfish, they kill other components too. So that's why you need a separate power or separate power supply for your motor. That's it. So here we go, guys. Why does motor need separate power supply? Okay, so this is the full thing I'ma teach y'all. Basically, when a motor runs, it kicks back an electricity. So it produces an electricity which it would throw back everywhere in a circuit, which is where it's connected, right? If it's connected to LED, like they share the same component, they would pry it, right? They would pry low voltage type of components, right? That's why you don't want it to be your neighbor, bro. And then number two, and not only it can heat up other component on a circuit, it could also grab all the current or the voltage. This starves whatever it's getting controlled with if they are in the same circuit. Basically, they are greedy on current and voltage. So that's why the other components would burn or heat up. Okay, number one, the solution is use a diode so it won't bounce the current back. So basically, a diode stops an electricity going back. That's it. Number two is the solution on number two to number two is use a capacitor. So basically, when a capacitor charges up, it gives voltage and electrical current. That's why when we use a capacitor, it gives the what you call this, it gives the motor, yeah, it gives the motor an extra boost of current and voltage. So that's why the motor needs a separate power supply. Okay, and then last but not the least is basically just a short circuit. So I guess this one is pretty easy. Let's just So basically, guys, short circuit is just when you directly connect negative and positive. Oh, I forgot positive. Positive without anything stopping the electrons. It would heat up infinitely because the current becomes so massive. Like, that's it. It would short circuit. It would heat up, overloading the battery. Overloading the wire or where it's connected to, meaning it would short circuit, it would heat up, and then it could it could even destroy the battery or swell up or explode. That's it. So finally, hold on. I'm done with all five of these. Whew, so we already done the things we need to do. So we just gotta check it up. Number one, done. Number two, done. Three, done. Number four, done. So thank you guys for watching. I hope you all enjoy my content, and please subscribe because this thing does too much. Bye bye.